Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to everyone. So today we are going to present about one of the topic in chapter 2, which is Green's theorem. So before we start, let me introduce our team members first. So the first one is me, Muhammad Afiq Mukhriz bin Shahruzain. Next, Muhammad Adam Hafiz bin Nur Muhammad Amin. And lastly, AHMAD ZULHAKIM bin Azhar, and we are from group CS2485B2. So for the first one is introduction. According to Stewart 2016, Green's theorem is named after the self-taught English physicist George Green from 1793 until 1841. The theories of electricity and magnetism, as well as a study of fluid movement, all depends on this theorem. A simple closed curve C has a positive orientation if the region D, region bounded by C, stays to the left of C as the curve is transverse. Based on the figure 1, shows the positive orientation and negative orientation of the closed curve C. So the Green's theorem is derived from the integration of the dot product vector field and Fndr, where the vector field Fx equal to Pxyi plus Qxyj. On the right side shows the double integration of Q differentiation respect to X minus P differentiation respect to Y.
Assalamualaikum and a very good day. My name is Muhammad Adam Hafiz bin Nur Muhammad Amin, and I will present the manual calculation for question 1. As you can see in the slide, the question asks to evaluate the line integral, which is the integration of f dot dr, where fxy is equal to x plus xy square I plus 5xyj, and c is a closed curve oriented counterclockwise as shown in figure 1. So this is the calculation. Stated in the slide is the formula of Green theorem. The formula is the integration along the curve C, p dx plus q dy equal to double integration of qx minus py dA. Therefore, we need to find the value of p, q, py and qx. P and q are from the vector field, so based on question 1, p is x plus xy square and q is 5xy. To find the value of py, we need to differentiate p with respect to y, which is 2xy. To find the value of qx, we need to differentiate q with respect to x, which is 5xy. Then, we substitute qx and py to the formula of Green theorem. dA can be either dx dy or dy dx, and for this calculation, we decide to use dx dy. Next, the limit of integration. We sketch a horizontal line in the region that parallel to x-axis. The left side of the line that attached to the line x equal to y is the lower limit, and the right side of the line that attached to the curve x equal to y square minus 5y is the upper limit of x. For y limit, it must be a constant, so we look at the y-axis. The limit is 0 to 4. Okay, next, proceed to evaluate the double integral. First, we need to integrate 5y minus 2xy with respect to dx, and then we substitute the limit of x, and then we do the second integration with respect to y and substitute the limit. Then we need to solve the calculation until we get the final answer, and the final answer of this question is -64. Thank you.
Hi, my name is AHMAD ZULHAKIM bin Azhar, and I will show how to get output for question 1 and question 2 by using Maple software. So for the first comment, we use linear algebra, which is used for linear algebra and vector calculus. So for the next comment, we will assign p into x plus x times y square, and we will get xy square plus x. Then we assign q into 5 times x times y, and the output is 5xy. Next, we will differentiate p with respect to y, and we will get 2xy. After that, differentiate q with respect to x and the output will get 5y. Next, we will set up the limit x is greater or equal to y and less than or equal to 5 times y minus y square. After that, we set up the limit y is greater or equal to 0 and less than or equal to 4. Lastly, we integrate and the final answer for question 1 is negative 64.
So next we move to the second question. The question is use Green's theorem to evaluate the integration of x square y square dx plus with the bracket of yx cube plus y square dy, where C is negatively oriented as shown in the figure 3 as below. So next, to answer the second question, firstly we need to state that P is equal to x square y square. Then we differentiate the P with respect to y and we get the 2yx square. Next, we state that Q is equal to yx cube. Then we differentiate the Q with respect to x and we get the 3yx square. So the next step is we need to find the limit for the integration. We identify that the upper limit and the lower limit. Then we get the limit for y from negative 2x to 1 over 2x. And for the x, we get from 0 to 8. Then we apply the formula of the Green's theorem. We get the integration of x square y square dx plus with the bracket of yx cube plus with y square dy equal to double integration of q differentiate with respect to x minus 2p differentiate with respect to the y dA. Next, we insert the limit that we get and also the value that we obtained just now for qx and py into the formula. For the dA, we can choose either dx dy or dy dx. So we decide that to use dy dx in this question. So next step, we solve the inner integration with respect to dy. Then we solve it by substituting the value of the limit inside the equation that we obtain. And we get the x to the power of 4 over 8 minus with 2x to the power of 4. Then we solve the outer integration with respect to dx. We substitute the limit and lastly we obtain the answer is negative 12,288. However, since the equation states that C is negatively oriented, so we need to modify the theorem by adding a negative in the formula, which is in front of the double integration of the formula. Therefore, we get the answer is equal to 12,288.
So for question 2, the first command we will assign p into x square times y square and we will get x square y square. Then we assign q into y times x cube plus y square and the output is yx cube plus y square. Next, we will differentiate p with respect to y and we will get 2x square y. After that, differentiate q with respect to x and the output will get 3x square y. Next, we will set up the limit y is greater or equal to negative 2x and less than or equal to 1 over 2x. After that, we set up the limit x is greater or equal to 0 and less than or equal to 8. Lastly, we integrate and the final answer for question 2 is 12,288. That's all from us. Thank you for watching.